Hello everyone. I posted a new blog article yesterday on the Gen AI topic on LinkedIn. In this article, I talked about the instruction fine tuning that would be recommended for enterprise implementation. I would like to share a demo today that I did it on the deep learning AI lab as part of the exercise I did it on AWS Sagemaker. I used a Flan T5 model that you could see one of the large language model where you can see a lot of foundation model or large language model. This Flan T5 that's used for text summarization could be for classification, translation, and many different tasks. So let me get onto the SageMaker. If you can go there, so this is a I did it on deep learning.ai lab. So kind of clear all the kernels data, clear all outputs. So once you go there, this is my file is strict fine tuning instruction model. So I'm trying to install the Python and other transformer data sets. So some of them is already used the package, so we don't want to worry about it. We can ignore those errors. And then I'm going to load the data set. So this data set, I'm loading it from Hugging Face website. If you go to the Hugging Face website, where you can see a lot of test data that can be used for a data science project. This particular one, I'm going to use a data set for the dialogue summary data set. So what does that mean is, if you look at that one, you can see the ID and dialogue and summary information and then topic. So this is a data we are loading it to our model, and we are going to give a training, and then we are trying to get the model generation output. So that's the purpose we are doing it. So I'm trying to load all the data set and also loading transformer, a tokenizer, and trainer. I'm going to use a PyTorch as part of this programming script. So I'm trying to run this particular section. It is done, and I'm trying to load the Hugging Face data set, which I already talked about it. This is a dialog summary data. So loading all this data, you could see it. It's all done. Now I'm going to load the model. As I mentioned, I'm going to use the base model is Flan T5. And we are trying to load this model. So you're trying to and tokenizing all the data into the vector. And then I'm going to see how many parameters it has been trained from this model. You could see that one, the train parameters of this base model. So it's busy. You can see that one 247 billion parameters it has been trained. It's pretty large. As I mentioned, this is a default base model of Flan T5. So we're going to take some random data set, and we are trying to see the model response. So when you try to do the prompting, we are having a starting the prompting is summarize the following conversation, and we are trying to give the data, that particular data from the summary data here. Look at this one. So we're trying to get the ID of 200, taking some sample data, and we are going to see the input parameter and a human summary, and then model generation zeros short inference. So we're going to see the model inference data and also compared to our human summary data. So look at that one. So you can see that one, the baseline human summary data. This is what we do have it, and model generation zero shot inference. So that's giving the responses. I'm thinking of upgrading my computer. So it doesn't tell a little bit more details. It's telling like a more at the higher level. So we want to make it a little bit more better response. That's our intent. So that's why we're going to do the instruction fine tuning model, and the human summary is better than the model generation response. So we're trying to give like a lot more human tailored data. We're trying to provide to the model on top of the base model so that our response is going to be more accurate. So that's our intent. So now we are going to start the performing fine tuning model. Okay, full fine tune. We are going to do that. As part of that one, you can see that one all the tokenization. We are going to do it with our data set. So running it here. So in other words, it's all converting the data into the vectors. So it's trying to more tokens getting created. That's part of the model generation. We want to convert everything into tokens, and then we're going to load into the tokenized data set. We are loading, and you can see that one the data set sample. We are trying to take a training data set is going to be 125, and then validation 5 and 15 we are going to do for test purpose. So this we are trying to load a sample data. We are trying to load into that. And as part of this fine tuning, instruction fine tuning, as I mentioned, we are trying to provide user tailored data so that the system or model, the base model, can try to take our instruction fine tuning on top of it. So it's going to be the top layer of base model. So the response is going to be far better than what it used to produce. So this is a summary training. So I want to show that one summary training, how it's going to look like. This is a human tailored or user tailored information. So you can see that one, the data here, this is going to be the dialogue, and you can see the summary data. You can see there must be some comma. It's going to be the other parameter will be there. Not able to see it my eyes. So look at that one. This is going to be the summary data we're providing. So like that, we are trying to provide large amount of data set. So this is going to be the tailored data, how the response is supposed to be, the formatting, tone, and structure. Everything can be done through fine tuning. Sometimes the model generation output could be a little bit rude, or it may not be having a right tone. So with the fine tuning, we can try to make it better formatting. So that's the intent. So we're trying to load this training data. We're going to take a small subset. We're trying to take it. You can look at that one, learning rate, and also epics. Where is that? Epics are going to be there. So we can see that epics and also max steps is there. Okay, so then so all the parameters we're trying to give, the training parameters we're trying to provide. Yeah, here it is. Training epics. Okay, 1. Usually if it is going to be epic 5 or 6, it's going to be a better accuracy. That means there's so many iterations, and also the max steps that you can go up to 100. So then it's going to be more better performance. For our sample or demo purpose, I given 1 because it's going to take more time to train. When I try to generate this one, let's kind of load it. It's going to take a while, and then it's done here, and then training is going to take more time. So it may be taking up to 2 or 3 minutes. Oh, so it's working there, I guess. Still it's loading the data. Start training there. One, it's a busy. Since it's going to take 2 to 3 minutes, and then it's going to load this one, train this data. I'm going to put this video on pause until this is done. Okay, until this training is complete. You don't want to wait for 2 to 3 minutes. If I use more, number of epics are increasing, it's going to take even more time. So I'm going to put that video on pause. Now it's ready. So you could see that one, there could be some training loss when you try to train the data, and the data all got loaded. So now I'm trying to load it from the cloud storage, because this is already trained information. What we did, that one was previously only a small sample. Now I'm trying to take that one fully trained instruction fine tune model. I'm getting it from the cloud storage. So if you look at that one, the size of the instruction fine tune model, it's up to 1 GB. So when you try to have the initial data, that's a large amount of data, but that was trained with the base model. But this is read or instruction fine tuning. It's close to 1 GB of data. We are trying to do it. All right. So done. Still is busy. All right, it's done now. So now I'm going to do the next line instruction. I'm creating an instruction model. I'm loading that data, the fully trained data, I'm loading into the instruct model. So in other words, the base model is going to be our FLAN-T5 model. Now we are going to have the instruct model. We are going to get the output against instruct model. Instruct model is going to be a new layer on top of the base model. So let me load this instruct model. Let me execute this line. So now the instruct model object is going to be ready now. It's ready. So now I'm going to test it, some qualitative validation. We can validate this one. The same output, we are trying to give a prompt against our base model. And we are going to look at the human baseline summary. And then we are going to look at the instruct model summary. So our expectation is the instruct model summary is going to be better than human summary. So that's our intent. So we're going to take the index 200. It means a random record we are going to validate. So you could see the output from all three. Baseline human summary is person 1 teaches person 2 how to upgrade software and hardware in person's 2 system. So original model, this is a human summary. Original model says you would like to upgrade your computer. Person 2, you'd like to upgrade your computer. That doesn't make sense, right? It's not that powerful. Instruct model message, we're getting the new response based on the instruction fine tuning. Person 1 suggests person 2 upgrading person's 2 system, hardware, CD-ROM drive. Person 2 thinks it's great. Wow, this very powerful response compared to the human summary or original model, isn't it? So now I'm going to look at the quantitatively, I'm going to measure it. How well right my model has responded based on the instruction fine tuning, and also compared to the base model, we're going to compare each other. So which one is giving a better result? So ideally, instruction fine tuning model should be much better than the baseline summary model. So we're going to use the metric name called Rouge. The Rouge is one of the metric that's used for the text summarization. There are various metrics that is going to be used, one for translation, blue, and Rouge is typically used for text summarization. So now we are going to load it. All right. So now we are going to load the 10 records, 0 to 10. So we're going to see the summary of 0 to 10 records, at least 10 records. We're going to look at it, compared to model summary or baseline summary and the instruction fine tuning summary, the original model summary and instruction fine tuning summary. We're going to look at it, how the results are going to look like. So it shows busy. It means it's working. Come on. So we're almost done. After this line executed, we're going to look at the metrics comparison. So which metric has given a better response or better results? We're going to look at it. Again, it takes a while. I'm going to put this video on pause so that you're not going to watch 20-minute video. All right, it's ready now. So as I mentioned, there are 10 records. We're going to look at it, random sample, human baseline summary, and original model summary. This is against the base model. This is executed against instruction fine tune summary. So when you look at each one of them, so obviously the instruction fine tune model summary is going to be better. When you try to expand it, we can see more information. So let's look at the quantitative metric, that is Rouge metric. Let's see what this metric is giving. So look at that one, Rouge, right? 0.2, instruct model is 0.4. Rouge 2 is 0.1, 0.17, 10 and 17. And you can see each one of them, it's better than original model. So the instruction fine-tune model, the metric is far better than the original model. So that's what it tells for these 10 metrics. Now we're going to load the entire data set, not just for 10. We're going to see all of them. What is going to be the metric Okay, how far it is better than the original model's results or model metrics. So I'm going to load all the data, and then we are going to compare the percentage. All right. So you can see all the entire data set loaded, the entire instruction fine-tuning model set loaded. When you try to compare the original model and the instruct model, so look at that one, 0.2 to 0.4, and a Roosh 0.07, 0.18. This is a wow, far better. So when you say Roosh, Elsam, and other things, it's going to be a long sentence. It's going to be starting with the unigram to the long sentence. It's comparing. That's where you're seeing Roosh 1, Roosh 2, and everything. So now we are going to compare it in terms of percent. So look at that one, absolute percent improved of instruct model over original model. Roosh 1, 18.82%. That means it's better than the original base model. And Roosh is 2 is 10.43 and so forth. So hope it gives a good glimpse of instruction fine-tuning techniques. There are other effective methods that are also available, like LoRa, meaning low rank adaptation, and soft prompts or prompt tuning as part of the parameter efficient fine-tuning model. So there are many methods are there. So I can even continue this parameter efficient fine-tuning, but that I have not talked about it, this particular technique in my blog, because fine-tuning is instruction fine-tuning is far better. We can also go efficient fine tuning. It's something where we want to make it even more simpler, or we want to do different technique, we can apply for it. So anyway, I hope it helps. Thanks for watching. If you have any question, please contact me. Thanks again.